right?
I don't even go to that yet. You're getting ahead.
Okay.
I want to keep, guys, now let's do, with that in mind, and it always takes about 5-10 minutes to explain what's going on in the details, right? Now let's do the first rule. We're starting for current 1, current 2, current 3. We're going to do through Kirchoff's rules, okay? So the first one says, any junction point, at any junction point, the sum of all currents entering the junction plus equal to the sum of all currents leaving the junction, which is what we said, right? I'm going to do this one right here. And it doesn't, by the way, you'll have the same equation for this and this, but it doesn't matter. So I'm going to do this. I1 plus I what? I3 equals I2. That's your first, you have 3 unknowns, you need 3 equations, don't you? We have 1 equation so far. We get the other 2 from the second rule. All right, that's the first equation. I need 1, I need 2 more. All right, now these are loop rules. Okay, ready? This says the algebraic sum of the change in potential or voltage around any closed path of a circuit must be 0. I'm going to do, you have the option of 3 paths here, 3 closed paths. I can either do, and I can go clockwise or counterclockwise, it doesn't matter. I'm going to go the direction I think current's going, but that's another story. But I have 3 closed paths. I have either this one, or this one. Everybody clear? There's 3 possible loops there. I'm going to do, let's see, I need a black magic mark. Here we go. I'm going to do this one. And then I want to make it quick. I will do.
Didn't you do the big one, the minus?
Is the big one easier? Oh, it is, isn't it? Then we will do this one. I did not do that last period, but I think that's easier, okay? Everybody got it? I could have done this one here, right? Yeah, there's more work than that. Yeah, you have 1, 2, 3. Okay, let's do that. They would have been the same. Oh, you know what? Let's go with this. That's fine. That's fine. I mean, I don't want it. Okay, guys, so I need to get an equation for this loop and for that loop. You with me? Okay, now remember, when you go through a loop, when you go from where you start around to where you and stop at the same place, right? Voltage in equals voltage out. You with me? That's what this is all based upon. So what we'll say is then, I'm going to say, so let's see, let's start right here. We're going to do this loop here, okay? So we go through the battery the right way, that's plus 80 volts. I'm not going to put the units here, it just messes you up. Okay, then we go from here to here, right? That's going to be, now we're going with the current is drawn, correct? And it's I2 in this part down here. So it's going to be minus, can I do 1 times I2? I like to put the number first. We know this V equals IR, right? I'm going V equals RI. Same thing. Because I want it to look like algebra. All right? So we got that, and then we go through this. What do I write for that? Minus
20 I2.
20 I2. Now I go here, correct? Because this is the loop I'm going. What do I write for when I go across the battery?
Plus 45 volts.
If I go with the battery, which I'm doing, right? All right, so it's going to be plus 45.
Wait, you go against the battery?
Yeah. If you do, it's minus. All right? Now I go across this one. What do I write for that?
Minus 1 I3.
Yeah, because I'm going with the current is drawn, and it's current I3, right? So minus 1 I3. I hate when I do that. And then I go through that one. And then I come back to home, and I go through no more resistors or batteries, right? I come back to here.
So that should equal.
All this equals what?
0.
There you go. Makes sense? All the volts in, let's see what all the volts out. Therefore, the voltage must act to 0 when I go through a closed path.
Why were they negative?
Because if I go through a resistor, the way I have drawn the current, I'm dropping voltage, right? When you go through across a resistor, you're dropping voltage if you go in the direction of the current. Okay? All right, so that's 1. Let's simplify this a little bit, guys. Just 80 and 45 is 125. And let's see, the I2 is minus 21 I2. And then minus what?
41 I2.
That's not bad. So far we have 2 equations. And I need a third one because I have 3 unknowns. And we're going to do the second loop here. All right, I'm going to use another marker, guys, because I don't want to run out my black marker. All right, so I'm going to start here again, plus 80 volts. And I go once again minus I2.
Doing the big one, right?
Yeah. If you want to put I minus I220, same thing. And it messes some people up if you don't do that. And then we go here, don't we? We go through that one, right? So what do I write for that?
Minus 3I1.
Minus 30, I1. Yep, equals 0.
That was 3.
All right, let's simplify that a little bit. Not much, but a little bit. There you go. So there's our third equation. Okay. Now we're going to solve for it. Okay, everybody ready? Now the first thing, getting the first equation, getting the first current takes you time. The second two pop. Well, as soon as you get the first one, you're almost there. Because getting the second two would take you about 30 seconds, okay? But the first one is a pain in the butt. First thing I'm going to do is this. I'm going to plug in, let me make sure before I do anything else. That's I1 and I2. I'm going to substitute into this to give me an I1 and I2 as well, okay? So I'm going to do this. I'm going to substitute into this thing right here to get rid of the I3. You follow me? Because this doesn't have an I3. Think about it, guys. If I have this equation I1 and I2, this equation I1 and I2, two equations, two unknowns, I can solve for either one, can't I?
It's just algebra.
Yeah, it's just algebra. So I'm going to do this. So I have this. I have I3 equals I2 minus I1. Let that for I3 right here. Let's get after it, okay? All right, I'll rewrite that thing, so it'll be 125. And I'm going to write the other one down there. Let's just strip this out before I do anything else. Okay, let's add the I2s together. I'm going to get all those details out of the way so when I'm ready to do it, it goes quick. Okay, and now I'm going to write that last equation down there up here. All right. Well, now that I have these two right here, now which one you want to solve for, I1 or I2? Doesn't matter. Let's solve for I2 then. So here's, let me pull that over here, do an isolation. On actually I2, and that'll plug in that into I2 here. You with me? Let's do that. So I have this, 125. I'm going to skip a step, but it's nothing major. If you don't follow it, just say something. Oh, I did a mistake there. Right? Then divide by 62, you get and then you have, now I got to use a calculator.
For you to get 62 from.
21 plus 40.
Add these. Okay.
Oh, wait, you moved it to, I get it.
So 125 divided by 62 equals. And 64. Oh, I left one little thing off, didn't I? There you go. So that's I2. Let's plug that into this thing right here. And solve for I1. And that's the hard part. That's not too bad. And watch my math there, guys. 2/3 of 21 is 14. That should be right. Yeah. Okay. And let's see, add these together. And it's going to be 44.
Where did you get the 122?
Yeah.
122?
8
Yeah.
minus 42
Yours
is
was 38.
38.
Oh. I should subtract it, shouldn't I?
Yeah.
Sorry about that. Let's redo that. My mistake. I'm so glad I have a smart board.
I think being smart kids is
Shut up.
Okay.
Yeah.
It's okay, that's what I heard.
Okay.
Oh.
So what's 30 divided by 44?
46, 36,
Wait,
36,
Mr. Brent, isn't it plus 14I? Oh, wait, just okay, because you're negative, right? And then, okay. I get
Say it again, Greg.
0.86, 36, 36, 36, 36,
Two sig things.
0.86.
Sounds a little disappointed there.
Hey, what's the book give for it? 0.87? That's fine, that's fine. All right, now, that was the hard stuff, guys. Thank goodness it's 3. Now let's do the easy stuff. Which one do you want to solve for first? By the way, I can use, let's use, now there's, remember that, guys.
You put it in there.
Okay, I got I1, and
The 2.0 plus point.
use this one, right? You can use any equation that you've gotten along the way. Any equation, you with me? I won't play into this because that's easy to do. All right, let's do that.
Mr. Brandt, can't you just do the 2.0 plus
On your right, the
0.6?
Right here?
Yeah.
Oh, yeah, you can. That's even easier, right? Very good. Like I said, any equation that you have used along the way applies. What do you get for it?
2.6 cents.
Point what?
6.
0.60?
2.6.
2.6.
Oh, do you want?
No, that's good. Just what you said is great. Now, what's the quickest way to get I3?
I3 equals I2 minus I1.
There you go.
Ah, so it's-
That one right there, much quicker. So I2 minus I1 is I3. Okay, and let's see. Oh, what? Let's see.
1.7.
Yeah. Easy enough?
Well, you on the AP test, probably.
Here's what they made do. By the way, here's what I do on quiz on this kind of stuff. I'm not about you because we're going to solve for all the currents. What do you think I will do? I will say, I'll give you a circuit like this, and I'll say, give me 3 equations that you could use to solve for the currents.
Oh, that's just.
Wait. How was
Well, I would say, give me the 3 equations that you would use to solve for the 3 currents.
You just wouldn't have
Can you make solving for the transaction right?
Yeah.
I have to think about it. Extra credit at this point is, guys, you have to understand what my mission is, what my guiding light is. Why do you think I give you these quizzes that you don't study for?
Because you want us to fail.
Yeah, you got it. I'm a wonderful teacher.
You like that.
I want you to feel pain when you don't take care of business. Because if you don't feel pain, what happens? You won't change. Nobody does. You understand?
Why do I wake up in the morning so I want you to feel pain?
But, Mr. Brown, beat out morphine, because you can't put pain whenever you have morphine.
Well, Mr. Brandt, don't give morphine.
Good, that's an opiate. If you started getting more.
Well, yes, I would get a little bit trouble, wouldn't
That's
I?
very large.
Now, guys, here's my question to you. Do you want me to give you a circle on the board and set up your equations before we get out of here? I want to give you a circle on the board. You set up your equations. I want 3 equations. We're not going to solve them. You're just going to write them out, okay?
So is that I one?
Well, we have 3 minutes, so go.
Yeah, well, we got to.
Can we? Was that like I1 plus I3 plus I2? Always one of them. Like the very first.
Yeah, that's one of your equations.
Well,
Yeah.
your number of substitutes could change it.
So just do the first 3
Just a second. Look.
The entire room.
All right, guys, that one right there. Give me 3 equations. 3 equations. Oh, man, that's good enough. And that doesn't take you long to do, does it?
Nope.
Give me 3 equations, guys. That should take you about 2 minutes, maybe a minute. And you can all do different loops, can't you? Why is that not getting right?
Is it tested?
He said one.
I don't know, but you can see that's the main thing.
Yeah, the same.
So it's gonna be like it's gonna split up right again.
See, let me just.
The current.
Yeah, junctions.
I'm gonna show you my loops. You can do whatever loops that you want to do. This loop, and I'm not even looking at it, and those are my 2 loops. Okay? Yeah, and that's probably right. Do from there, guys. Those are your 2 loops. All right, now when you cut them on, it's not a grade. Just see if you got it right, okay?
So we use
So-
those 2 loops?
Yeah, and my guess, is if you look at this, guys, once I'm thinking it goes here, here, here. You know what I mean?
That's what I kind of put.
With that in mind, give me the 3 equations and check them all, and I'll have mine down when you get here tomorrow. I1, I2, I3. Don't solve it unless you want to. Just get the equations.
And when you do this, you always start from the biggest count.
You can start anywhere that you want to.
Okay.
Well, I would tell you this. I'm going to start right here. But it doesn't matter where you start. It really doesn't. But I'm going to start here for this one, and I think I'll start here for the upper one, okay? But it does not matter.
It doesn't matter how you start. It matters how you finish. That's every cliche poster. Boy, such a
I look over at Brandon and I was just like, no man, they're cool. Let's just go to a business meeting.
Yeah.
Thank you for the gig.
You stop it on me like how do I stop it? Mr. Brand, did you stop recording? No.
Thank you. Appreciate that.